Okay, good morning to everybody. Today we'll discuss about the inverse Laplace transformation. First of all, what is inverse Laplace transformation? In our earlier classes, we have studied about Laplace transformation, the properties of Laplace transformations, and today we will learn about the inverse Laplace transformation. So, if Laplace transformation of original function f of t equals to f of s. So this is the f of s is the transformed function. Then the inverse transformation, then the inverse Laplace transformation, inverse Laplace transformation f of s is f of t. That is, symbolically we can write inverse Laplace transformation f of s equals to f of t, where L inverse is called the inverse Laplace transform operator. Okay. For example, if you the inverse Laplace transformation of 1 by s minus 3, inverse Laplace transformation of s inverse 3 equals to what will be e to the power thrice t. Okay, because since Laplace transformation of e to the power thrice t equals to what was 1 by s minus 3. In our previous lecture, we have proved this result. This is the example 1. Similarly, example 2, what is the inverse Laplace transformation of 1 by s square minus 9, s square minus 9. This equals to 1 by 3 sine hyperbolic thrice t, because since Laplace transformation of sine hyperbolic t, what was Laplace transformation? What was the sine hyperbolic t formula? What equals to here 3t. Okay, so 3 divided by s square minus 9. So in this way, we can solve any inverse of Laplace transformation. For example, 3, Inverse Laplace transformation of 1 by s square plus 25. What will be? This equals to 1 by 5 sine t formula. That means sine 5t equals to 5 here, because Laplace transformation of sine 5t, what was 5 divided by s square plus 5 square. Okay, this is the main example of inverse Laplace transformation. Now, important example 1, find the inverse Laplace transformation of 6 divided by twice s minus 3 minus 3 plus 4s divided by 9s square minus 16 plus 8 minus 6s divided by 16s square plus 9. Now to find out the inverse Laplace transformation of this. So inverse Laplace transformation can be denoted by 6 divided by twice s minus 3 plus 4s divided by 9s square minus 16 plus 8 minus 6s divided by 16s square plus 9. So for this inverse Laplace transformation, we can rearrange this whole term. Rearrange inverse Laplace transformation. This is the operator for inverse Laplace transformation. So this can be written as, we can take here common what? We have to free the coefficient. That means we have to take the coefficient of s from every term. Okay, so we can write 2, if 2 common here, 6 divided by 2 common s minus 3 by 2. Okay, minus 3 plus 4s divided by 9 common here. If we take 9 common, then what can be written as s square minus 16 by 9. Okay, plus 8 minus 6s divided by, if 16 common, then s square plus 9 by 16. Now inverse Laplace transformation over, we can write 3, 2 and 6 will be cut by 2, minus here this can be written as here 3 plus 4s. So we can divide it into 3 divided by this whole term. That means we can write 1 by 3 divided by what? S square minus 4 by 3 whole square. Another term plus minus what will be 4s divided by 9. Okay, so 4 by 9 into s divided by what will be? Same, s square minus 4 by 3 whole square, plus we get another 2 term from here. One is 8 divided by this whole. Okay, 8 divided by this whole means what? 8 by 16 means what? Half. Okay, half divided by s square plus 3 by 4 whole square. Another was plus minus 6s by 16. That means 6 by 16 means what? 3 by 8. 3 by 8 into s divided by s square plus 3 by 4 whole square. This is the first term, and from here we get 2 term. Okay, 1 by 3 divided by this, plus minus 4s divided by this. Then from here another 2 term, 8 divided by this whole, we get this, and minus plus minus 6s divided by this, we get this term. So there are how many term? 5 term. Okay, 5 term here. So we get right, we can write here inverse Laplace transformation over 3 divided by 3 divided by s minus 3 by 2 minus, here we can write 1 by 3, 1 by 3, and another is s square minus 4 by 3 whole square. So if we take 1 by 4, then we can write 4 by 3 here, okay, to make similar term for fitting the formula for inverse Laplace transformation formula, because this term and this term will be same. This is why you have to multiply it another 1 by 4. Now to make this similar term, how we have to multiply it? Minus 4 by 9 we have to multiply it, because this will be 16 by what will be 4 by 9. If we divide it by 4 by 9, then we get s divided by s square minus 4 by 3 whole square. 4 by 9 just writing in a side, plus we have to make 3 by 4 same, okay. So we have to take 2 by, if we take 2 by 3 here, then we get 3 by 4 divided by s square plus 3 by 4 whole square minus 3 by 8. If we take this 3 by 8 in this side, then we get s divided by s square plus 3 by 4 whole square. So the inverse Laplace transformation of each term, because for minus you must know constant divided by, okay. For plus, this is minus also. There are two minus and there are two plus, okay. This is the what parameter divided by, and this constant divided by this parameter divided by, okay. So you must know about the inverse Laplace transformation formula. This will be what? 3 into what will be s minus a formula, e to the power a t, okay, e to the power 3 by 2 t minus, then 1 by 4. This formula what will be? A divided by a square minus a square formula what will be? Sine hyperbolic a t, okay, sine hyperbolic 3 by 4 t minus 4 by 9. This will be what? S divided by a square minus a square formula what? Cos hyperbolic a t, okay, cos hyperbolic a t 4 by 3 t, a means 4 by 3, okay, plus 2 by 3 a divided by a square plus a square formula what? Sine trigonometric function sine a t, okay, sine a t formula, sine a means what? 3 by 4t minus s divided by a square plus a square formula what? Cos a t, 3 by 2 cos a t, a means what? 3 by 4t. This is the result. Just using the formula we can find the result for this inverse Laplace transformation. Okay, now another example, example 2. Find the inverse Laplace transformation of 14s plus 10 divided by 49s square plus 28s plus 3. Actually, s is the parameter of transformed function. So we have to find out the original function. Inverse Laplace transformation means what? Inverse of this equals to original function. That means the function will be on t. That means the independent variable will be t. But in Laplace transformation, the parameter variable transform to what? S. So remember it. T is the variable of what? Original function, and s is the variable of transformed function. We have to remember this. So the given function 14s plus 10, 49s square plus 28s plus 3. This can be written as we can write it as a like this 14s plus 10 divided by 49s square plus 28s. We can write 49 means what? 7s whole square. That means we can make a perfect square like this. 7s plus 2 whole square plus 9. Can we write this? A plus b whole square formula. 7 whole square means 49 square. Twice ab. 2 to 4. 7 multiply 28s. Then 4 square. Then 2 square 4. So here we get only 3. Sorry, this will be 13. This will be 13. Okay, 13. So from here we get 4 and 4 plus 9 what? 13. So this can be written as 14s because we have to take common from the parameter coefficient 14. We have to make it coefficient free. Okay, parameter will be coefficient free. So s plus 10 by what? 14. After taking 14 common, but we have to make the parameter same. How? This can be written as, if we take common 7 here, then we get 49 common. Okay, s plus 2 by 7 whole square plus 9. So to make it same, 2 by 7, you have to add that what? Maybe 6, because 14 multiply this 4 and 6 what? 10. Okay, we have to s plus 2 by 7, s plus 2 by 7 same. Okay, just making the same function, same term in both numerator and denominator. Therefore, now inverse Laplace transformation of 14s plus 10 divided by 49s square plus 28s plus 13. What will be? Inverse Laplace transformation of this will be inverse Laplace transformation of this. Sorry. Inverse Laplace transformation of what will be 14s plus 2 by 7 plus 6 divided by 49s plus 2 by 7 whole square plus 9. So after this line, we can write e to the power at. Here a equals to what? Here at equals to what? E to the power a means minus 7 minus 2 divided by 7 t. E to the power minus at, our inverse Laplace transformation of our (14) s plus 6 divided by 49 s square plus 9. Okay. Now that means using this shifting property, we can write just this s plus a transform to only s. That means s plus a transform to only original function. But this is not yet original function, but this output will be the original function f of t. Remember it. This is the inverse Laplace transformation of this means what? F of t. according to the definition of inverse Laplace transformation. So using this shifting property, this a equals to what here? 2 by 7, because there are minus, this is plus, this why they are minus, this is plus, this is why minus, remember it. So a equals to here 2 by 7. Okay, so just using this one here, we can write this equals to e to the power minus 2 by 7t inverse Laplace transformation. We can take 14 common here, right? And 49 common from here. So 14 divided by 49 s plus 6 divided by 14 divided by s square plus 9 by 49. Okay, this equals to e to the power minus 2 by 7t. So inverse Laplace transformation of this can be written as, you can write, this is the constant term, this is why you can write this one. So inverse transformation as divided by this, okay, as divided by s square plus, this can be written as what? 3 by 7 whole square, right? 3 by 7 whole square plus 6 by 14, 6 by 14, 14 by 49 multiply 6 by 14 inverse Laplace transformation over 1 divided by s square plus 3 by 7 whole square. This is the third bracket, because e to the power minus 2 by 7t is the multiplied to whole. 2 by 7t. This is the inverse transformation formula. What will be? 14 by 49 multiply, what will be the formula here? 7 by what will be? S divided by s square plus s square formula, what will be? Cos at, cos 3 by 7t, 3 by 7t 2. So there will be 7 by here 14 divided by 49 multiply 7 by 2, what will be? 7 by 7 by what? By 7, only one. This plus what will be this multiplication? 14 6 by 49, 14 will be cancelled, 6 by 49. This formula what? Sin 80, sin 3 by 7t. Six by 14, 7 by 3 multiply 7 by 3, 80, and here will be 7 by 3. So after this line, e to the power minus 2 by 7t. Here will be 2 by cut. What will be cut? 7 will be finished. This will be finished. 3 by 7. This is the 3 by 7. So cos 3 by 7t plus 7 cut and 2 cut. So we get only 2 by 7 sine 3 by 7t. Just using the same formula. Now another example 3, using a multiplying by s property. Okay, inverse Laplace transformation of s into f of s. That means multiplying by s property equals to what will be ddt of original function f of t plus f of 0 into del t. Okay, we have proved these properties in our previous lecture. So to find the inverse Laplace transformation of multiplying by s, multiplying by s, multiplying by s. So how to solve these types of problem? That means using multiplying by s properties. So first example is will be what? The inverse Laplace transformation of s divided by s square plus 1. How we can find this? Actually, this equals to can be written as we can write using the multiplication of s, this one ddt of what will be ddt f of t, f of t, f of t plus f of 0 into del t. Remember it, f of t equals to what? Inverse Laplace transformation of 1 by s square plus 1 equals to what will be? You must know this is the formula of sine t. That means this is equals to what? F of t. Okay, f of t. So this will be ddt of f of t means what? Sine t. Sine t equals to 0. For t equals to 0, sine 0 equals to what? 0. Okay. Del t means what? Differentiating partially this. What will be? Cos t. Okay, sine t differentiation what? Cos t. This equals to ddt of sine t what? Differentiation. This equals to cos t. This is the result. Now second one, inverse Laplace transformation of s divided by 4s square minus 25. How we can find this? Using the shifting property. So we can take common 4, 1 by 4, inverse Laplace transformation s divided by s square minus 5 by 2 whole square. Can we write? So this equals to 1 by s square by 5. So this can be written as this equals to 1 by 5. This equals to s divided by s square minus s square. Formula what will be? There will be multiplied with 2 by 5, 2 by 5 inverse Laplace transformation of what? S divided by s square minus 5 by 2 whole square. So this equals to 2 by what? This can be written as, sorry, this is 1 by 4. So 1 by 10 into this inverse Laplace transformation formula what? What will be? This inverse Laplace transformation formula what will be? Here as multiplying by s property. 1 by 10 sine hyperbolic at t. Sine hyperbolic 5 by 2 t. This is the result. Now, example 3. Inverse Laplace transformation of p s divided by twice s plus 9. This can be written as sorry, this using this one, actually I have to make it this way. Using this one, ddt of what was f of t plus f of 0 del t. Here, inverse Laplace transformation of 1 divided by 4s square plus, sorry, minus 25 equals to what will be? To get the original function f of t, 4 will be common, 1 by 4 inverse Laplace transformation of 1 by s square minus 5 by 2 whole square. So this formula will be what? 2 by 5 inverse Laplace transformation of, sorry, 1 by s square minus s square formula, what will be? Sine inverse sine hyperbolic at t. Sine hyperbolic 5 by 2 t. This is the original function, 1 by 10. This is the f of t. Remember it. F of t equals to sine hyperbolic 5 by 2 t. So using here this concept ddt, f of t equals to what? 1 by 1 by 10 sine 5 by 2 t plus f of 0, what will be? Sine hyperbolic 0 equals to what? Sine hyperbolic 0 equals to what will be? Sine hyperbolic 0 equals to 0. Del t, what will be del t? Cos hyperbolic 5 by 2 cos hyperbolic 5 by 2t. So just finding the original function f of t, original function, just f of t values what will be 1 by 10 sine hyperbolic 5 by 2t. Then f of 0 equals to what will be 0 and 1 by 10 10 del t means what? Partial differentiation of this. So we get this one. Sine differentiation what? Ordinary differentiation. This is the ordinary differentiation. Okay. General differentiation. So cos sine formula cos hyperbolic this. First multiplying with the coefficient of t. Okay. This is the rule for differentiation. We have to multiply with the coefficient. So we get 1 by 4 cos hyperbolic 5 by 2. Okay. Now.
It to mention, sir, please. It to kindly.
Okay. Okay. Okay, now third part of this example, using the multiplying by s property. Okay, how to find the inverse of this? First of all, we have to take 3 divided by twice s plus 9 without multiplication. What will be the inverse of this? Okay, you must know after taking this is the twice s. Okay, twice s plus 9. So we get 3 by 2 here, inverse Laplace transformation 1 divided by s plus 9 by what? 2. Okay, 9 by 2. You must know this is the formula of what? Formula of what will be? E to the power minus at formula. Okay, e to the power minus 9 by 2 t. This is the original function f of t. Okay, Now inverse of this, what will be? Just putting d dt of 3 by 2 e to the power minus 9 by 2 t. F of 0 what will be? 3 by 2 e to the power minus 0 into 9 by 2 into 0. Okay. And del t what will be? E to the power and del t equal to what will be? F of t of 0 into del t. This equals to differentiation what? Original differentiation 3 by 2 e to the power minus at formula e to the power minus at. Okay. Minus 9 by 2 multiplying with the coefficient e to the power minus 9 by 2 t plus e to the power 0. E to the power 0 means what? E to the power 0 means 1. Okay. So we get 27 by 4 minus 9 by 2 t plus 3 by 2. This is the result. Okay, now another property, important property for solving inverse Laplace transformation, 1 by s property, 1 by s property or multiplied by 1 by s. When division by in previous one multiplying by s property, but now division by s property, divided by s property. That means we have to use integration for division. Okay, division of this parameter s as dividing by s. Okay, dividing by s property. So you have to multiply the integration with the inverse Laplace transformation of f of s, which will be the original function f of t. You must know this is the inverse one. This is the original function f of t. So using this property, how to solve inverse Laplace transformation? So here, in first example, 1 divided by s into s plus a. Okay. So how to solve these types of problem now? Therefore, inverse Laplace transformation of 1 divided by s into s plus a equals to what will be? 0 to t, 0 to t, inverse Laplace transformation, 1 divided by s plus a to t 1 by s plus a dt. Okay, dt according to the definition, this one. So you have to find out first of all the original function. Original function will be what? Inverse Laplace transformation of 1 by s plus a. What will be? E to the power minus at, right? E to the power minus at. You must know from the formula chart of inverse Laplace transformation. So this will be 0 to t and inverse Laplace transformation e to the power minus at dt. Okay, this is the f of t. Remember it. This is the f of t. Okay, so 0 to t e to the power minus at dt. Simple integration. This will be what? E to the power x at t dividing with the coefficient of t. Okay, then upper limit and lower limit. Okay, just putting upper limit a to the t equals to t, we get 1 by a minus e to the power 0. What will be? 1. Okay, so we get actually 1 by a into minus will be multiplied. So e to the power 0 means 1. Okay, 1 minus e to the power minus at. This is the simple result. That means inverse Laplace transformation of this one.
Yes, sir. Yes, sir.
Now next one, just a little bit different. This will be the s square. Second one, s square, s into s square plus 1. Okay, so this will be just s square, a little bit different. This will be the s square, and original function will be what? Inverse Laplace transformation of 1 by s square plus a. This formula, what you must know, this formula equals to sine t. Okay, sine t from the formula chart of inverse Laplace transformation. So this equals to what will be sine t. Sine t. Now, very easy. Sine t formula what will be? Sine t formula. This formula integration what will be? Minus cos t and 0 to t. So minus cos t minus cos 0 degree. 0 degree means what? 1 minus cos t. This is the formula. And this is the result, 1 minus cos t. Now third one s square plus 3 divided by s into s square plus 9. Okay, so s square plus 3 divided by s square s into s square plus 9. So how to find this as an inverse Laplace transformation now? Okay, using the property of 1 by s property, multiplying by 1 by s property. Okay, or divided by s property. So this can be written as inverse Laplace transformation of what will be s square plus 3 divided by s into s square plus 9. This can be written as inverse Laplace transformation over s square plus 3 can be written as what? Here s square plus 9. So we can write s square plus 9 minus what will be 6. Okay, making partial fraction. Okay, making partial fraction, we can write s square plus 9 divided by this, what will be 1 by s. Okay, s square plus 9 divided by this whole, we get 1 by s minus 6 divided by what will be s into s square plus 9. Okay, so there are two parts. Now inverse Laplace transformation of 1 by s minus inverse Laplace transformation 6 divided by s into s square plus 9. Inverse Laplace transformation of 1 by s, what? You must know 1. So this means what? Using the 1 by s property, what will be? Before solving the, example 3, we solve 2. The 1 by s into s square plus 1 here. Okay. So just using this concept, we can find 2 into 0 to t f of t, what will be? Sine thrice t here, sine thrice t dt, because original function what? Original function was inverse Laplace transform 1 by s square plus 9. What will be? Sine thrice t. Okay, this is the f of t. Okay, sorry, 3 into sine thrice t. Okay, so just putting 3 into sine thrice t means what? The 6 become 2. Sorry, this will be 1 by 3. Okay, 1 by 3. So 1 by 3 multiply 6, what? Only 2. Now 1 divided by 2 into sine formula, what? Integration minus cos, right? Dividing with the coefficient of 3, upper limit and lower limit. So this equals to 1 minus plus 2 by 3 cos thrice t minus cos 0 degree. Okay, this equals to 1 plus 2 cos thrice t minus 1. Okay, this is the result. Okay, now another properties. First shifting properties for finding the inverse Laplace transformation. The first shifting property can be written as like this: inverse Laplace transformation of f of s plus a equals to, this equals to e to the power minus a t, e to the power minus a t, inverse Laplace transformation of f of s. So using this property, how we can find the inverse Laplace transformation? So for example, we can solve an example, suppose like this. Find the inverse Laplace transformation of, first one is 1 by s plus 2, number 2 s divided by s square plus 4s plus 13, 1 by 9s square, 9s square plus 6s plus 1. Actually, how to find this example? Okay, first example, 1 by s plus 2 whole to the power 5. Just using this shifting property, how we can find this one? You must know inverse Laplace transformation of 1 by s plus 2 whole to the power 5 can be found if you want to find the original function. Original function will be what? Inverse Laplace transformation of 1 by s to the power 5. What will be? T to the power 4 divided by 4 factorial. Okay, this is the f of t. So inverse Laplace transformation will be, substituting this shifting property, we can write e to the power a equals to what? 2. Okay, e to the power minus twice t, this one, inverse Laplace transformation of 1 by s to the power 5. So this equals to 1 by twice t. This equals to what? T to the power 4, 4 factorial. So this is the result. Now second one, inverse Laplace transformation of s divided by s square plus 4s plus 13. How we can find this? You can write inverse Laplace transformation. This can be written as s plus 2, s plus 2 minus 2. We can write this s plus 2 whole square. Okay, twice ab plus b square 4. So 4, 13 minus plus 9. Okay, 4 plus 9 equals to 13. So to make the partial fraction, we can write this one in this way. So inverse Laplace transformation can be written as s plus 2 divided by this, okay, s plus 2 divided by s plus 2 whole square plus 3 whole square. Another one, inverse Laplace transformation 2 divided by s plus 2 whole square plus 3 whole square. Okay, so using linear property we can write this. Then now shifting property. Shifting property will be s e to the power twice t inverse Laplace transformation of what will be s divided by this s plus 2 become s square plus 3 square, okay, minus e to the power minus twice t inverse Laplace transformation over s square plus 3 square. Here 2 2 will be multiplied, so we can write there is a constant. This is why we can divide with another one. That means we get 2 by 3 into what will be 3 divided by s square plus 3 square. So e to the power minus twice t inverse Laplace transformation, this formula what? Cos thrice t, okay? Cos thrice t minus e to the power minus twice t. This will be formula of what? Sin thrice t. Sin thrice t. This will be 2 by 3. So this is the result. Now another one, third part of this. Third part of it will be what? Third part, inverse Laplace transformation of 9s square plus size 6x plus 1. This equals to, can be written as inverse Laplace transformation of 1 divided by this, can be written as thrice s plus 1 whole square. Okay, thrice s plus 1 whole square. So here to free the coefficient, we can take common 3 here. So we can write 1 by 9 inverse Laplace transformation over 1 divided by s 1 by 3 whole square. Okay, so this means 1 by 9 inverse Laplace transformation of, can be written as by using this shifting property. This s plus a become f of s, that means e to the power minus 1 by 3 t f of inverse Laplace transformation of what will be 1 by s square. Okay, 1 by 9 e to the power t by 3. This means what? Inverse Laplace transform 1 by s square equals to only t by using the formula chart. Okay, so this is the result. Very easy. That means we can write t into e to the power minus t by 3 divided by 9. This is the result. This is the result. Now another example by using the same properties, shifting properties. So inverse Laplace transform, find the inverse Laplace transformation of s plus 1 divided by s square minus 6x plus 25. So inverse Laplace transformation of this can be written as inverse Laplace transformation of s plus 1 divided by, this can be written as s minus 3 whole square. Okay, x minus 3 whole square plus 3 9 and 16 equals to 25. So we can write this one. Okay, this can be written as inverse Laplace transformation of here s minus 3. So we can write s minus 3 plus 4. Okay, to make s plus 1. Now s minus 3 whole square plus 4 whole square. So this s minus 3 can be shifted by using the shifting property. Okay, so by using this one we can write inverse Laplace transform by linear property, s minus 3 divided by s minus 3 whole square plus 4 whole square plus inverse Laplace transformation of 4 divided by s minus 3 whole square plus 4 whole square. That means inverse Laplace transformation of this, what will be, by using shifting property, equals to constant minus at. Minus I means for minus 3. So minus minus plus, it will become 3t. So inverse Laplace transformation of what will be? Inverse Laplace transformation of s divided by s square plus 4 square plus inverse Laplace using same property, e to the power u to the power thrice t, e to the power thrice t, inverse Laplace transformation of 4 divided by s square plus 4 square. So this means what? Just using formula, this will be what? If parameter s exists, then it will be cos. So cos 4t plus e to the power thrice t. This will be sine 4t because there is constant and there is parameter. This is why. So this is the result for this example. Now another important properties for finding inverse Laplace transformation. This is called actually second shifting property. So second shifting property, inverse Laplace transformation of e to the power minus s f of s can be shifted f of t minus a u into t minus a. There are two types of function. One is f, another is u after second shifting. Okay, so there are two functions. This is why actually second shifting. Now we can solve this example. Find the inverse Laplace transformation of e to the power minus 5t divided by s plus 3. So how we can find this example? Now original function here, original function, we have to original function inverse Laplace transformation of 1 by s plus 3. This can be written as e to the power minus 3t. Okay, so this can be written as inverse Laplace transformation minus pi, sorry, this will be pi s. Okay, pi s, not t. So this is the total s function, that means transformed parameter will be s exist here. So after transforming using this second shifting property, we can write e to the power minus 3 t minus pi. Okay, here t minus a. Okay, here a equals to pi. This is why t minus pi u into what will be u into t minus a, that means t minus pi. This is the f of t function and this is the u function. Okay, this become f of t function and this u function. So this is the main result. Now we can find another one. another example, just using example 8. Example 8 can be found like this. Suppose we have inverse e to the power inverse Laplace transformation of e to the power s. 3 into e to the power 3 into e to the power minus thrice s divided by s square. Okay, so how to find the inverse Laplace transformation of this actually? Okay, now another example 8. This is the example of in finding inverse Laplace transformation by using the second shift property. So this can be written as inverse Laplace transformation of e to the power minus s 3 into e to the power minus thrice s divided by s square. This can be written as by using linear properties. This can be written as e to the power minus s divided by s square minus 3 into e to the power minus thrice s divided by s square. So you must know there is a property Laplace transformation of u into t minus a. U into t minus a can be written as e to the power s divided by s. Okay, minus s. E to the power minus s divided by s. So, and Laplace transformation of t minus a u into t minus a u of t minus a can be written as e to the power minus s divided by s square. So using these two uh, shifting property, using this one, okay, using this one, we can write inverse Laplace transformation of this one, inverse e to the power minus s divided by s square 3 e to the power minus thrice s divided by s square. Okay, so using this one is t minus 1. Here coefficient of s is 1, t minus 1 into u into t minus 1 minus this will be 3, this 3 and t minus 3 u into t minus 3. This is the result. Very easy one. Now another properties, derivative properties for finding inverse Laplace transformation. So derivative properties will be now the derivative properties the derivative properties will be inverse Laplace transformation derivative properties, inverse Laplace transformation of DDS f of s equals to minus t inverse Laplace transformation of f of s. This equals to minus t f of t. This is the derivative properties of Laplace transformation. Derivative properties of Laplace transformation. This also can be written as like this. This can be written also like this. Inverse Laplace transformation of f of s equals to minus 1 by t Laplace transformation, inverse Laplace transformation of d ds f of s. We can write also like this. For example, to find out the inverse Laplace transformation of uh, inverse Laplace transformation of log s plus 1, log s plus 1 divided by s minus 1. How we can find this? So for finding this one, inverse Laplace transformation of log s plus 1 divided by s minus 1. This can be written as minus 1 by t minus 1 by t Laplace transformation of d ds of f of s. That means log s plus 1 divided by s minus 1. Okay, minus 1 by t minus 1 by t inverse Laplace transformation of this will be differentiation with respect to s. Okay, so differentiation of dds of log s plus 1 minus dds of log s minus 1. Okay, so minus 1 by t inverse Laplace transformation of log formula what 1 by x. Okay, log x formula 1 by x. Okay, 1 by s minus 1 with respect to s. So 1 by t. Now we can find the easily. This is the formula of e to the power minus t minus e to the power t from the table of inverse Laplace transformation 1 by t. So just we can write 1 by t multiplying minus, we get 1 by t e to the power t minus e to the power minus t. So this is the result for finding inverse Laplace transformation for this example by using derivative properties. By using the derivative properties. So now we can find the inverse tan inverse 2 by s square. Tan inverse 2 by s square. Okay. So inverse Laplace transformation of this can be written as using this property minus 1 by t inverse Laplace transformation dds tan inverse 2 by s square. Okay, this equals to minus 1 by t inverse Laplace transformation of differentiation of tan inverse x. That means 1 by 1 plus x square formula. Okay, tan inverse x formula. So 4 by s to the power 4 multiplying again differentiation of 2 by s square. Differentiation of 2 by s square means what? Minus 4 by s cube. Okay, so this equals to minus 1 by t inverse Laplace transformation of s to the power 4, s to the power 4 plus 4 minus 4 by s cube. Okay, so this equals to minus 1 by t inverse Laplace transformation minus s divided by s4 plus 4. And this minus will be cancelled. So we get only s divided by s to the power 4 plus 4. Now by partial fraction, we can write this 4. By partial fraction, we can write this one s divided by s to the power 4 plus 4 can be written as like this. S divided by this can be written as s square plus twice s square plus twice s plus 2 s square minus twice s minus 2. Sorry, this will be minus twice s plus 2. If you multiply, we get this easily. Okay, so this can be written as 2 part 4 by t inverse Laplace transformation of this can be written as this minus this in numerator. So we get 1 by 4 1 by s square plus twice s plus 2 minus plus 1 by 4 1 divided by s square minus twice s plus 2. So we got this by partial fraction method. So this can be written as 4 by t inverse Laplace transformation minus 1 by 4. This can be written as s plus 1 whole square 1 by s plus 1 whole square plus 1 plus 1 by 4 divided by s minus 1 whole square plus 1. Okay, so 4 by t inverse Laplace transformation, just using the laws or formula from the formula chart, we can write e to the power minus t into sin t. Okay, and this 4 will be common. Okay, sin t plus e to the power t sin t. For t minus 1 we get plus t, for t plus 1 we get minus t. Remember it. 4 will be cancelled, 1 by t this is the inverse Laplace transformation formula. 4 will be cancelled and sin t will be also common. Sin t divided by t e to the power t plus e to the power minus t. Sorry, there will be minus because minus 1 by 4. So we get this will be minus. This is the result. A very easy one for finding the inverse Laplace transformation by using derivative properties. Okay, now another important properties for finding inverse Laplace transformation is integral properties. So uh, for finding the inverse Laplace transformation by using integral properties, that means the inverse Laplace transformation of 0 to infinity f of s ds, this is the transform function and this is the original function f of t. This integration 0 to infinity can be written as f of t by t. This equals to 1 by t. This f of t can be written as inverse Laplace transformation of f of s, or this whole can be written as inverse Laplace transformation of f of s equals to, what will be this, equals to t into this one. Okay, inverse Laplace transformation of 0 to infinity f of s ds. Now we can solve any example by using this inverse Laplace transformation method. Integral transform. Suppose we are using inverse s cube by s4, s cube by s4 minus a to the power 4. How we can find the inverse Laplace transformation of s cube divided by s4 minus a to the power 4? So this can be written as inverse Laplace transformation of, this can be written as s into s square divided by, this can be written as a square minus b square formula, s square minus s square and s square plus s square. So this can be written as like this, s divided by 2 s square plus s square minus s square minus s square. Okay, okay, my s square will be twice s square, sorry, this will be s square will be cancelled. Okay, uh, inverse Laplace transformation, this will be minus, sorry, this will be plus and this also plus, so s square will be cancelled, then we get, so inverse Laplace transformation of this can be written as s divided by 2, 1 divided by this whole equals to s square minus s square plus 1 divided by, what will be, s square plus s square minus s square minus cancelled. So this is the inverse Laplace transformation of this by using partial fraction method. So this can be written as half can be taken as a common constant multiple method. So inverse Laplace transformation of s divided by s square minus s square plus inverse Laplace transformation of s divided by s square plus s square. So just using the formulas from the chart, we can write cos hyperbolic at t, cos hyperbolic at t plus this will be what, cos at only, because plus sign. So this is the result for finding the partial fractions method. Now how to find the inverse Laplace transformation, 1 by s to the power 4 plus 4, 1 by 1 by s to the power 4 plus 4. How to find this? By using the integration method. You have to use integration method here. That means integration property, integral property. First of all, we can write s to the power 4 plus 4 equals to, can be written as s square plus 2 whole square minus twice s whole square. Okay, this can be written as this. So this means what? A plus b into s square plus twice s plus 2 a minus b. Okay, this can be written as like this. So now inverse Laplace transformation of plus 4 can be written as inverse Laplace transformation over 1 divided by s square plus twice s plus 2 s square minus twice s plus 2. And this can be written as 1 by 4s square plus twice s plus 2 minus twice s plus 2. 2 will be cancelled, s square will be cancelled. So twice s plus twice s. What will be? 4s. 4 will be cancelled, ss will be cancelled. So this can be written as like this. So 1 by 4 inverse Laplace transformation 1 by s into what? This divided by this will be 1 by s square minus twice s plus 2 minus 1 by s square plus twice s plus 2. Now using the same property, we can write now here inverse Laplace transformation of 1 by s square minus twice s plus 2 equals to, you must know, this equals to, in our previous example we got this equals to what? Inverse Laplace transformation 1 divided by s minus 1 whole square plus 1. Okay, this equals to e to the power t what? Sin t. E to the power t sin t. Similarly, another one, inverse Laplace transformation over 1 by s square plus twice s plus 2. What will be inverse Laplace transformation of 1 by s plus 1 whole square plus 1. So this equals to e to the power minus t sin t. So now using the integral property, how we can find 1 by s integration will be what? So integration will be 0 to infinity f of s ds. F of s means what? we get e to the power t sin t, e to the power t sin t, e to the power t sin t, sorry, it will be 0 to t, 0 to t to the power t sin t minus e to the power t, e to the power minus t sin t dt, 1/4. Now this will be the formula of 0 to infinity e to the power t sin t will be common, e to the power t minus e to the power minus t sin t dt. This is the UV process. So doing UV process, we can find the result. 1/4, this will be 0 to t. So dividing by S property, using the dividing by S property from our previous examples. So using UV process for this, e to the power t cos t sin t minus cos t minus e to the power minus t. This will be minus sin t minus cos t. So this will be the result. E to the power minus 2 divided 2. This is the result. Okay, now another example. Find the inverse Laplace transformation of s plus 4 divided by s plus 4 divided by s into s minus s square plus 4. So let us first resolve we have by using partial fractions. So s plus 4 divided by s into s minus 1 s square plus 4 can be equivalent to, there are four variables in the denominator. That means the dimension of variables is 4. That means s to the power 4 produced. So we have to introduce 4 constant. So a by s, we can take a fraction. Another will be b by s minus 1, and another fraction can be written as cs plus d, because for s square, for this square, we have to introduce as cs plus d divided by s square plus 4. So after taking common here, we can make the partial fraction. So by using partial fraction method, how we can find the Laplace transformation of this? By using partial fraction method. Okay, by using partial fraction method, how we can find the inverse Laplace transformation? So by using a partial fraction method, we can find s plus 4. How to find example 12? How to find the inverse Laplace transformation of s plus 4 divided by s into s minus 1 s square plus 4. Okay, how to find this? First of all, taking s minus 1 s square plus 4, this equivalent to partial fraction a divided by s plus b divided by s minus 1 plus cs plus d divided by s square plus 4. Or we can write s plus 4 divided by s into s minus 1 s square plus 4. This can be taken as LCM. So s minus 1 into s square plus 4 into a plus s into s square plus 4 into b plus s into s minus 1 into cs plus d. Okay. So from both sides we can write as denominator will be cancelled. So s plus 4, because this is non-zero for areas. So a into s minus 1 s square plus 4 and b into s square plus 4 plus cs plus d into s minus 1. Now if from here, suppose this is example 1, if s equals to 0, then if s equals to 0, this term and this term become 0. So then from 1 we get 0 plus 4 equals to a into 0 minus 1, 0 plus 4, all term are 0. Okay. So a equals to what? From here a equals to, we get 4 divided by 4, only 1. Now if s equals to 1, if s equals to 1, then from equation 1 will give s equals to 1, then 1 plus 4 equals to 5 equals to, this becomes 0 and this becomes 0. So b into 1 into 1 square plus 4. So from here b equals to, we get 5 divided by 5, also 1. Okay. Now equating the coefficient of s cube, because to get c or d we have to multiply it with cs in multiplied with s square. That means s cube, equating the coefficient of s cube in 1, we get s cube coefficient here 0. Okay, in left hand side, and here s cube coefficient is a. Okay, and here s cube coefficient is what? B. And here s cube coefficient what? Plus c, right? cs cube, and other are omitted because there are no s cube. So from here just putting a and b equals to 1, then c equals to what will be? Minus 2. Sorry, we got a equals to, here a equals to minus 1, here minus 1, this will be minus 1, sorry, and b equals to 1. So a equals to minus 1 and b equals to 1, c equals to will be 0. So now the real function, this is the suppose main fraction, okay. So hence s plus 4 divided by s into s minus 1 s square plus 4 can be written as a divided by m is what? Minus 1 divided by s plus b means 1 divided by s minus 1 plus 0 divided by, okay. So cs, c means what? 0, but there is another constant for finding d. Now if we equate the coefficient of s, now another one, equating the coefficient of s in equation 1, equating the coefficient of s here only 1. Okay, in left hand side 1, and here as coefficient what? 4s, that means 4a. Okay, then here as coefficient is plus 4b, and here as coefficient what? Minus d. Okay, that means we get 4a plus 4b minus d. From here, putting the values of ab, we get d equals to what? D equals to -1, a equals to -1 and b equals to 1. So d equals to -1. So just putting, hence we can reduce the fraction s into s minus 1 s square plus 4 can be written as a equals to 1 divided by s minus 1 divided by s plus b equals to 1 s minus 1, and c value 0, s means what? -1. So we get -1 by s square plus 4. This is the by using partial fraction method. Now we can find the easily inverse Laplace transformation of this. So inverse Laplace transformation of this can be written as, hence inverse Laplace transformation of this can be written as inverse Laplace transformation of -1 by s plus 1 by s minus 1 minus 1 by s square plus 4. Because this fraction, by using partial fraction method, we can write this. So this means what? -1 by s formula plus 1 by s minus 1 formula minus inverse Laplace transformation of s square plus 4. So this means what? -1, 1 by s equals to -1, and this will be e to the power t. Okay, e to the power t minus this will be half sine at, a means 2 sine twice t. Okay, because inverse Laplace transformation s square by plus a square formula is 1 by a sine at. Using this one, we can write this. So this is the required inverse Laplace transformation of the original function given. Similarly, we can solve this, find the inverse Laplace transformation of this one, thrice s plus 3 divided by thrice s plus 3 divided by s minus 1 into s square plus twice s plus 5. So inverse Laplace transformation of this will be given, but first of all you have to transform into it into partial fraction method. Okay, so there are highest power is s cube in denominator of the polynomial s cube. So we have to introduce 3 constant here, abc. So a divided by s minus 1 is another one constant, and another will be for s square present, we get bs plus c. Okay, so using the same procedure, taking LCM, denominator and denominator will be cancelled. So numerator equals to a into this plus bs plus c into s minus 1. Okay, so comparing the coefficient of s square and s from the both sides of this, we get s square coefficient a, here s square coefficient is b. Okay, so here s square absent, this is why 0, and coefficient another one is twice a minus b plus c equals to 5. So from these 3 equation we can solve for a b c. Okay, so finding a b c equals to 1 and c equals to 2, then putting this here we get b equals to -1. Then this total fraction can be written as 3 parts. Okay, so inverse Laplace transformation of this can be written as inverse Laplace transformation of this partial fraction. Okay, 3 parts. So this means what? E to the power t, and this means what? By shifting property, e to the power minus t, inverse transformation of this. By using shifting property, we can write as plus 1. We can e to the power minus t, this. So this is the result, very easy one.